Uranium is one of the only elements that can undergo nuclear fission. That's why it's used for nuclear fuel. But how does uranium ore turn into nuclear fuel, and what happens after it's used? First off, uranium is typically mined using in situ recovery. This is where a solution called lixiviant is injected into the ore through wells. This solution dissolves the uranium and is then collected in a series of recovery wells. After this, the solution is pumped to a processing plant where the uranium is extracted through an ion exchange process. The uranium is then further processed and dried to produce yellowcake. At a uranium conversion facility, the yellowcake is then processed and reacted with fluorine to create uranium hexafluoride gas. It's then cooled into a liquid. Over 5 days, the liquid forms into a solid and is then transported to an enrichment plant to be enriched. It needs to be enriched because the UF6 has different isotopes of uranium in it. It has about 99.3% uranium-238, 0.7% of uranium-235, and less than 0.01% of uranium-234. Uranium-235 is the isotope that undergoes nuclear fission, so its concentration needs to be increased in order to sustain a fission chain reaction. In the United States, a gas centrifuge process is used to enrich uranium. This is where UF6 gas is placed in a centrifuge and rotated at a high speed. The rotation creates a strong centrifugal force, causing the heavier UF6 containing uranium-238 to move to the outside. The lighter UF6 containing uranium-235 gathers towards the center. The stream with a slightly higher concentration of uranium-235 is moved to the next centrifuge. A gas centrifuge facility has long connected lines of these cylinders. At the end of these lines, the UF6 is enriched to the desired amount. Enrichment also leaves behind large amounts of depleted uranium hexafluoride. This waste is then transferred into 14-ton cylinders. Through deconversion, fluoride is chemically extracted to produce a chemically stable compound of uranium. This stable compound is now more suitable to be disposed of as low-level radioactive waste. The enriched gas is then cooled into a solid and then transported to a fuel fabrication facility. There, the UF6 is heated up to a gas and then chemically processed to form uranium dioxide powder. The powder is then pressed into pellets, sintered into ceramic form, layered into zirconium alloy tubes, and constructed into fuel assemblies. These fuel assemblies are now ready to be used by commercial light water reactors. Each pellet is about the size of a die, and each pellet has as much energy as 1 ton of coal. That's enough coal to fill the back of a pickup truck. After being used in a reactor, fuel assemblies are highly radioactive, so they are submerged in a pool of water for several years. After this, they are moved to a dry cask storage container at the power plant site. Now you know how uranium goes from ore to nuclear fuel.